Thank you, everyone, for joining this Control Central webinar presented by Schneider Electric. My name is Harshal Mahangre, and I'm the IT Director at Control Central. We know you're all really busy, and we appreciate you taking time out of your schedule to join this presentation. So thanks again for being with us. I want to just take a moment to mention a couple of things at the beginning of the webinar, and then I'll introduce our presenter. This webinar today is being recorded, so if there's someone with your company that wasn't able to join us, they can see it as well. We will be sending a follow-up email to all of you that are on the webinar today. So you'll have it as an on-demand recorded version. Also, I want to mention our presenter today welcomes your questions. However, we do have the lines muted so that we can have an undistracted presentation. So there's no one walking over anyone. But you do have a questions box and also a chat box on your GoToWebinar panel. And we ask you at any time during the webinar, if you have a question, just please type it in. And I know David will be glad to get to those at the end of each slide. I want to get right out of the way here. And our presentation today is from Schneider Electric. They are really an excellent supplier of Control Central. And I want to introduce David Moody. He's a Solutions Sales Support Manager at Schneider Electric Buildings Division. David, welcome and thank you. It's all yours.
All right, thank you, Harshal. I really appreciate the introduction, and welcome everybody to this presentation. And I thank you as well for taking time out of your day and spending it here on the call with us to see something pretty exciting that we're offering out of our organization. And but before I do that, just to touch a little bit more on my position within the organization and where I'm at. I'm located in Northern California, and I support out of our buildings division the mid-market type solutions, which is what we're here to talk about today. And in my role, I do a lot of different things. As you can see, my title as a Solution Sales Support Manager really means a lot of things in the sense that I work with our engineering and our R&D team to put together solutions and applications like this and help do testing. And as projects come in from the field or questions come in for projects where you may want to deploy a product like this that we offer, myself or someone that's on my team actually gets in, and we roll our sleeves up and help make sure that you're selecting the correct product and getting it applied properly in the field. And we typically support all of the different channels that we have within Schneider Electric and our direct sales folks and the folks that we have here on the call. So with that said, what we're here to talk about today is our VAV/VVT room controller. The model specific is what we call an 8250. And as far as the agenda goes, I'll just kind of go over that a little bit. We're going to talk a little bit about the background of VAV, where it fits, the actual model itself and the feature sets of that, all the networking features that we offer, and then there's just in general a more information where we go over a lot of details of this particular product, and then we wrap it up. As Harshal said, that as we go through this presentation, if you have any questions, please don't hesitate to type it out, and Harshal will bring those questions to the group. I always find that it's best to ask those questions while we're on the slide, but at the end, we can also go through some questions as well. So again, feel free to raise your hand if you will. So with that said, our first slide here is to talk about variable air volume, VAV. If you're on this phone call, you very well understand what VAV is, more than likely, right? So I'm not going to go through this slide in detail to talk about VAV, but just in general, VAV is an application that most all of us have seen, whether we're in a small facility or a larger facility, high-rise type facility. They all have VAV boxes to a certain extent. And the reason for that is to provide a more precise temperature control, saving energy, reducing part loads, all these different things that VAV boxes can do for us within our buildings. That's what they're there to do, right? So how do we control that, right? Typically, we have in larger applications, we have a product-specific device. And in this particular slide here, it's a comparative type slide to say, where does it fit, right? This solution is a little different than what you may have been exposed to in your life. Typically, VAV applications have devices that you're seeing here on the right-hand side. They're self-contained. And these devices that you see here as the MP and RP solutions are a Schneider product, but everybody makes them at some form or fashion in their own form, but they're self-contained, where you can see there's a damper actuator and there's a pressure transducer built onto it, and then communication, and maybe you wire some I/O into it, but it's self-contained. Typically, those applications are in your larger footprint type buildings where you're putting hundreds, if not thousands of them in, and they're typically tied back to an automation front end somewhere. Well, our solution does that as well, but it's more of what I would refer to as ad hoc. And we're going to show what that specifically looks like as we go through some more slides here. But what's unique about it is it's a device that does not need a front-end computer to tie it back to a system to access it and program it and do the air balancing and have an air balancer use some special software where they can go in and air balance it and spend time with additional resources on a project to help them do an air balance for them. This particular device is self-contained in a wall-mounted controller that's hardwired up to the VAV box, where the damper actuator and the pressure transducer and all of that lives. And at the end of the day, all of that comes back to a nice, clean interface on the wall that can address the VAV box and do the air balancing without any software, without any licensing, nothing. You absolutely need nothing other than plugging it in, turning it on, and enabling it and doing the configuration for it. So this slide deck is a great example of some of the different solutions that come out of that device. So with that said, this is going to start diving in a little bit into what that VAV controller looks like. And I've kind of covered some of that on this last slide here. But when we look at it, it's a lowest installed cost when it's compared to a traditional packaged type VVT solution. And what makes it unique is you can also put this in a existing system, an existing building that has maybe a failed device on a VAV box that's self-contained, and you can put this on the wall. Now all of a sudden you have a user interface. You can control everything from the front of that HMI by pushing the buttons on it, and you can still tie it back into your system. So again, no software, no licensing, there's no downloads that are required. You quite literally pull it out of the box, put it on the wall, wire it up, and everything that you would need to do would be configured through the various screens on it. And in this example, it's showing one of two setup screens, which happens to be the default screen. And you can kind of see there's a configuration menu, as well as balancing for the air balancer, set points and displays. And there's other screens as well, but that's just a quick example of some of the things that are in there. But most importantly is anybody can put these in. This is not something that you have to have an in-depth knowledge of how the VAV controller works, how it gets wired up. It's very simple to install. And where we see a lot of folks putting these in are in a lot of retrofits and smaller applications. If you have a project that's came up that has maybe a handful of VAV boxes, 15 or 20 VAV boxes in a system, and maybe your end using customer can't afford an automation system, which anything that's a more commercialized, larger packaged application requires an automation system, a front end computer to have that tied into, whereas this doesn't. It can be standalone and it operates and it requires all the configuration at the device itself. Any questions so far? Okay. So I'll move on to the next slide here. This slide is just a quick example of the applications that you can have with this particular device. We show 3 here, but there's actually 4. And if I look at the top left, this is an application, a very basic application with a pressure independent VAV box with reheat on it. And it's just giving you a quick example of there's a duct reheat and baseboard reheat. It has the capability to do that with the supply air temperature sensor as well. And most importantly, it's showing the different types of communication that can come out of this device. And we're going to dive into that in more detail as we go through the presentation. But real quick, you can see that this device can be a BACnet MSTP hardwired communication protocol. It can also be a BACnet IP via wireless with an optional Wi-Fi module plugged into it. And then we also have Zigbee Pro communications, which is not a network communication, but it's a communication to peripheral devices that can connect to this device. And we'll have a slide that we will go through and show you what that looks like as well. The next representation below is an application. It's really the same application, except you'll notice it doesn't have a flow sensor in it. This is what is referred to as a pressure-dependent application, and that's typically seen in VVT applications. So this one-room controller can do pressure-independent or pressure-dependent type applications. One thing that we're seeing that's coming out of the field in applications where there's VVT systems, and there's hundreds of thousands, if not millions of these products that are out in the world today that have been running for 20, 30 plus years that still have a laptop sitting in a mechanical room plugged into a panel that's running DOS. And that's how you get into your VVT system and look at it. And those systems are failing. Whether you know it or not, they're failing. This particular product is a prime candidate for a direct replacement for those applications. And in particular, if you have any applications where there are the trained VAV boxes that are the older boxes in a pressure-dependent application that have a worm drive, and it's a cone that's built inside of the box. So essentially, you can't replace the damper actuator, but you have, and it's working great, but you need to replace the controls for it. This particular product is a perfect fit for it, and we've seen a lot of customers having a lot of success in upgrading 30-year-old systems to something that is 21st century, right, with this particular product. So in that application, that's a pressure dependent. And then on the far right-hand side, we have an example of a pressure independent, but this is a parallel fan-powered box. We can also do a series fan-powered box. It's just not depicted here. So we can do both of them. And at the same time, we can do ECM fan control on that, a 0 to 10 volt ECM fan control. So if you're seeing those in applications, this device can do that as well. So real quick, this is super high level overview of some of the things that this particular device can do. And it talks a little bit about optional occupancy sensors and inputs and leak detectors and changeover sensors and things like that. I'm going to show you this next slide here that starts to talk about what those types of things look like as far as all of the inputs that come into this particular device. So this slide here is an example of everything that comes in and out of this device. If I start looking at it, you can see that there's configurable inputs I'm not going to read every single one of these that's on the screen here. You all can see that. But you can hardwire inputs into this for night setback and motion, window contacts. We also have a Zigbee product, and there'll be a slide that talks about that can do that via Zigbee, via wireless, directly to this device without a need for any kind of gateway or anything like that. The Zigbee devices talk directly to this. And when we get to that slide, I'll give you some good examples of where we've seen some success out in the field, where people have improved their comfort for their occupants by adding these sensors to this device. But again, as you kind of look through this, you can see you have the ability to wire pretty much any kind of input that you would want to it: filter, door, override, service switches, condensate pans, any of those types of things, condensate pan alarms, you can wire all that into it. Temperature sensors, pressure transducers, fans, and again, that example there shows that we can do that with ECM, or we can do that with on-off type control or 3-speed fan control. Baseboard heat, duct heaters, and then the damper actuators, right? So it's pretty inclusive from the sense of hardwired input and output, all coming back to this device with these devices mounted out in the field to be able to control a VAV box. Lastly, we see at the bottom here on the red side is the different types of communication protocols that you can wire into this device. BACnet MSTP, Modbus if you have that, or BACnet via Wi-Fi. And again, that's with a module that gets plugged into the back side of it and gives you a BACnet IP access to this. And then lastly, Zigbee field type devices. So moving on to the next slide here, again, talking about lowest installed costs when compared to traditional DDC controls. Overall, the theme here is that you have a device that goes on the wall, and you can do any and everything that you want to do to that VAV box right there on the wall. And this is an example of some of the screens that are in there. When one of the slides earlier, we were showing the setup screen, which is here on the far left. That screen, as you select different things within that screen, it opens up other screens. And in the example off to the far right, it's a great example of testing outputs. So you can quite literally set in front of that HMI and turn on your fan, or you can open and close the damper. You can use some of the spare I/O on it to turn lights on and turn lights off. And you can manually do that right on the screen. And then when you leave the screen or after it times out, those devices go back to their normal state. But those are all things that would traditionally need to be done with somebody sitting at a front end and somebody standing in front of the VAV box looking at it. And that all goes away with this product. Some of the other screens are some service screens here. And you can see that in this example, there's 8 of them. We're only showing the first 2, but you can quite literally go in and see all of the I/O and what's happening with it, with the temperatures. We're showing Celsius here, it does degrees Fahrenheit. But you can see changeover sensors, outdoor air temp, the humidity. You can see what kind of demands being called at the thermostat based on the cooling and heating demands, supply temperature. I mean, there's just a ton of information, again, that you would typically see back at a front end that you can look at right on the room controller. So this slide here talks about, again, more of the total installed cost and how we can make that lower for us. And in this example, it's specifically dedicated to the VAV air balancer, right? In a traditional system, somebody's sitting at a front end or somebody's carrying a laptop around with them and they're plugging into the VAV temperature sensor on the wall to talk to the VAV boxes. Again, that all goes away with this solution. And it's all put in front of you on the HMI on the room controller itself. So these are the 2 air balancing screens that you would see. And as you look at that, you can see where your airflow is, what the calculated set point is. This is where you would set your set points for all your different flows that you would need out of that VAV box. And then there's an actual balancing screen itself for the air balancer to put his flow hood on and enter the value that he sees from his hood, and it will do the offset and recalibrate this particular room controller, and that's it. I mean, quite literally, an air balance can be completely done on these two screens, again, without any kind of software and jumping up on a ladder.
David,
any questions?
Yeah, we do have a question by John Zappa. I'm not sure if you can see it in on your panel. So John's asking, is there a complementary RTU controller for this VVT controller for a complete system, like the VT7000 series you have had in the past?
Yes, that's a very good question. So we're specifically talking about the 8250 here as a VAV controller. So the entire family of the 8000 series room controllers, we have an 8650 model, 8650, which is an RTU controller. And to be specific, it's a typical RGYWOB terminals, right? So whether it's a split system or an RTU, it doesn't matter. If it's an RGYWOB, we have a specific room controller. It looks exactly like the one that you're looking at on the screen here. All the screens are the same, except they're specific to what an RTU is. So in a VVT application, you would use the 8650 and you would use the 8250, which we're talking about here. And if you tie those together into a system, something that can coordinate all of that, because we don't offer that coordinator at this very moment. But if you bring that into, let's just say, a Jace, pick your poison, whatever you use for that supervisory type control, you can bring those zones, as far as the 8250 goes, is a zone, and bring all of that in. You do your system weighting, and then you tell the RTU to do something, heat, cool, and then the zones operate in direct acting or reverse acting depending on what mode the system's operating in. So the short answer is yes, we have an RTU version. We also have a fan coil version, which is an 8350, 8350, and that is a 2-pipe and 4-pipe application for fan coil. And again, all the same hardware platform, it's just different firmware in it that tells it to do fan coil, RTU, or VAV. Hopefully that answered that question.
Okay, thanks, David. Yeah, that's the only question I see so far.
Awesome. So this next slide is, next couple slides actually are slides that talk about the VAV controller in the sense that, hey, I've installed them on the wall. They've been great as standalone devices, but now I want to integrate them into my building management system. Or you have an existing building management system and you're using product XYZ and you really want to try this because the interface is really neat and it's got a lot of features built into it. And it may offer more than what you're currently using. You replace that and you plug it in. And this example right here, it's showing it being wired back into via MSTP. So, and you can see that it's BTL tested and listed. You can also wire it via Modbus RTU. Believe it or not, there are folks that actually do use Modbus for networking devices like this together. We do see it often happening out there, but typically it's MSTP. The new word du jour, if you will, in the industry is all IP, right? So everybody's turning everything into IP over MSTP. So we offer a Wi-Fi card that you can add on to this device as a separate part number and bring it in via BACnet IP. So a lot of times we get folks that ask, well, can we run a Cat5 cable to this and bring it in via IP that way versus Wi-Fi? At the moment, no. And the reason for that is the PC board on this is very delicate on the backside in the sense of where this card gets plugged in. It's not really meant to have wires being jiggled around on it, if you will. So we're working to develop a device that will slide into that PC board that will ensure that we don't break that board when you're connecting a Cat5 cable to a dongle that may be connected to it. So I would imagine that will be coming out shortly, but at this moment, it's not available, Wi-Fi only. And to that point, it's 2.4 gigahertz. We don't offer a 5.0 right now. That's another product that we're working on to expand our Wi-Fi capabilities, but right now it's 2.4. And then this is just a pointing to a little bit more about installing it via Wi-Fi versus hardwiring. So this slide is our slide that we're coming around to talk about all the Zigbee devices that can connect to it. So we've talked about this device and all the things that it can do wired up to a VAV controller and hardwired motion contacts and door contacts and all these things that can come into it. We can also do all of that via Zigbee, and that's all self-contained to this device itself. Again, no gateways required for that. It just communicates back to that specific room controller. And here's some examples of the devices that we offer, right? There's a door contact and a window contact. There's two different occupancy sensors. One's a ceiling mount and the other one's a wall mounted one. And then we have a CO2 temperature and humidity sensor and a water leak detector as well. All of those things come back to this device and report data into it. What's important to understand too is each one of these devices feed into an energy conservation measure or functionality within the room controller itself. And I'm not going to peel the onion back too far on that, but for example, on the front of the room controller, you'll notice there's two little slots at the bottom of it. That's a light level sensor and a PIR detector. I'm going to skip over the light level for a second, unless there's a lot of interest that comes in specifically to a question, but it's there. It can be used for anything that you would want to use it for. But the PIR is specifically built to detect motion in the room, obviously. And then we have energy conservation features built into this room controller that allows you to say, after a certain amount of node detection, then go into a standby mode, which changes a set point from one value to a different value. And then after another period of time, it can go into an unoccupied value. But with the addition of door contacts, we also have a feature that looks at that PIR and it looks at the door. And probably the best way to think of this is if you put yourself in the mindset of being in a hotel room. You're in a hotel room, you're the only person in there, and you go out the door with a door contact on it. Obviously, there's nobody in the room, so there's no motion, and the door has been opened and closed, so that's what we refer to as a cycle. If that happens, and you've enabled that feature inside of this room controller, it will automatically go into unoccupied mode, right? Otherwise, it would just sit there and look for motion and stay in occupied and then maybe go into standby. But the point here is that all of these devices can come in remotely via Zigbee and feed into this device and provide you energy conservation measures. And I would say the most used feature that we see people use this on the Zigbee side of it is our occupancy sensors. Now, all of the occupancy sensors offer temperature at the same time. And what we see is, imagine a VAV box that has a temperature sensor in one room and it feeds 6 rooms. Typically, room number 1 is the one that controls the temperature and any kind of set point and the comfort zone, the comfort of the other 5 rooms. With the addition of these occupancy/temperature sensors, you can put them in the other rooms and make that value report back to the room controller here. And if it's occupied, then use that temperature for every room that's occupied. And you can select the highest, the lowest, the average, whatever you'd want to do. And we'll talk about how you do that here in a little bit. Instead of having one temperature sensor that commands, takes that input from all of those zones, all those folks that are out there, you can install these occupancy/temperature sensors and be smart about averaging temperature, not just an average of all of them, but an average of the ones that are occupied. So that's one of the benefits that we see folks using the Zigbee devices on this product the most.
Yeah, we do have a question, David. It's from Floyd Shipman, and Floyd's asking, are you able to locate the Zigbee devices?
Locate. Can we be a little more specific on what locate means?
Floyd, if you're listening, you can type it in the questions. Oh, okay. So he's saying if a device goes down. Okay.
So within the room controller itself, imagine every one of these devices, and you can have up to 20 of these in a room controller. If one goes down, you can see it in the room controller. You can go to that. If there's 20 of them, you go to any one of those 20 and you can see their statuses if it's not connected to a network, right? If it's connected to a network, then obviously that information is available back at your front end supervisor. So you can see the communication status, the battery status, and the actual values that are being reported by it as individual points. So if I look at a motion sensor, it has occupancy and temperature, then it has battery status and communication status. So those 4 BACnet objects for each one of those occupancy sensors that you can alarm off of and put them on graphics and do whatever you want. So hopefully that answers the question. So standalone, you can walk up to it and see it. And if it's on a network, then you can see them all on your front end.
Okay. Thanks, David. Yep. Floyd, thanks.
You're very welcome. This slide here talks a little bit about what we were talking about with the PIR sensors and the hardwired, this showing a hardwired sensor into it and then another wireless. But again, they can be wired or wireless. But at the end of the day, what this slide is really showing is the beginning of energy savings and being able to use these devices that are coming into it to help change set points, right? And then this slide here just kind of adds to that, where it talks about the, on the far left, it's occupied, and then there's a timer that you can configure. You don't have to use it, but it's there if you want to. And after no motion, then it goes into a standby timer period, and it can stay there if you like, but if you want to enable the timer for the next piece, which is unoccupied, after that time expires, it'll go unoccupied, and it will just stay there and unoccupied until motion is detected. And then at the far right, you can see it goes back to occupied. Again, energy conservation features that are built into this VAV controller to help reduce your cost. And as a little bit of a callback to the other products that we have out there, the other 8000s, the 8600, the 8650, sorry, and the 8350, they all have this built into it too. So there's nothing special about the VAV controller in the sense that it's the only thing that offers this. All of our products in the 8000 series product line can do this. So this slide here talks a little bit about the 2 different brands that we have. On the far left is the Schneider brand, and the far right is the Viconics brand. Same thing on the inside. The only thing that's different is the actual footprint of it. You can see that the Schneider is a little more square, and the one on the right, which is the Viconics one, has more of a rounded corner to it. They operate exactly the same. The way they display their short message, and I'll explain that here in a little bit, is different. The Schneider does it on the top, the Viconics does it on the bottom, but they're identical. The only thing about having one installed and using the other one in its place is the mounting plate for it is unique to that device, right? So they're two different mounting plates. And if you pull one off, you'd have to put the other mounting plate on it to use that particular device. But other than that, they're the same device. So you can see here some of the things on the screen that are popping up on it. And what's really unique about this device is that HMI that you're looking at, as far as the buttons that are in front of you right there, there are, I think we're up to 13 different arrangements of buttons that you can put on the screen. So by configuring the HMI look, you can turn on everything and you can start turning things off, right? And all of our 8000 series do this. If you don't want the set point adjustment on the screen with that little up and down arrow, you can remove it, right? If you don't want to see the buttons at the bottom of the screen, you can remove that. If you don't want to see the outdoor air temperature, you can remove that. If you don't want to see the room temperature and you want to see the room set point, you can do that. If you want to just have a set point differential where it's a plus or minus, you can do that too. So like I said, there's like 13 different ways that you can configure the way this screen can look. And again, you're just poking it in what I refer to is poking it in the eye on the screen and configuring it there. The other is the color. And on the right, you can see we're blue, and on the left, you can see that it's white. There's about a dozen colors that you can change this as well, right? So if you don't like white, you can change it to blue. If you don't like blue and white, you can change it to red, purple, and I'm not exaggerating, we have a purple color. Where people seem to like the colors the most is just beyond the fact that you can select one that may fit the architectural surroundings. We're going to talk a little bit about more how you can customize things in here, but we can customize this at the room controller, where if it's in heating, the screen's red. If it's in cooling, you can change the screen to make it look blue. And it can all do that with what I refer to as automagical, right? And we'll talk about what that looks like. The last thing that I wanted to show you here on this screen is at the very bottom on this slide, on the right-hand side, there's an image, right? You can upload your own custom image as the standby screensaver for this device. And after it times out, after I think it's 120 seconds, it will go to the screen from the normal HMI screen. Whatever that screen is, whatever you want it to be, if you save that file and upload it into this device here, it can be your company logo, it could be your customer's logo, it could be your service number, it could be instructions, it could be anything that you like, and it would be in that screen there. And then lastly, we have what we call a short and a long message capability. The long message is what you see on the left, and that's where you can use the BACnet long message. And if it's in a BACnet system, obviously you can type a message and send that down. And in today's world, that could be things like shelter in place. If it's in hospitality, drinks, manager's bar, open, 7 o'clock tonight, or whatever you would want to put in there, you can display that at the room controller. What we don't have is a good example of our short message, but on the left-hand side, on the Schneider Electric, right above where it says occupied, all the way across the screen, you can put a short message there too. And that message can be anything that you like that fits on the screen as well, right? And those messages can be sent via BACnet, or you can embed them through what we call an uploader tool, which we'll be talking about here next. And you can make it display a particular message if something happens in a room controller. And maybe the door is open and it's been open for 10 minutes. You can make a message say the door's been open for 10 minutes. You can do anything you want from that perspective. So this slide is going to talk about what I've been referring to as our uploader tool. This is a free tool. It runs on Windows, and it allows you to do firmware updates. It allows you to upload that image, that screensaver image. It allows you to do a save and restore, so you can plug into a room controller. You can save its configuration and go plug into another one and restore that configuration into another room controller. And lastly, it also allows you to do an upload for what we call a custom Lua file. And this is the one thing that is very unique about this device and all of our 8000 series. We call them a room controller specifically because they're not a thermostat. They are actually a miniature controller. They've been specifically built with firmware in them to do a specific function. But if you don't like that function, or you need to, what I refer to as mutate that function, they also have the capability to have custom programming put in them. Our custom programming is built on a language, it's called Lua. If any of you have ever had any kids that have played any video game on the face of the earth, I'm pretty much guarantee you that it was built on the Lua software. That's just basically where Lua was started from, was in the gaming community. With that said, we have a very, very stripped down version of Lua to the point where it's very simple to do. It's text-based editing. There's no software that's required. You can open up any text editor, whether it's Word, Notepad. We like to use Notepad++ ourselves, but any text-based file, if you open it up and you just type out a script to look at objects inside of the room controller to say, for example, if I'm in heat, then I want the screen to be red. If I'm in cool, I want it to be blue. If I'm not doing anything, I want it to be green. That's an example of what Lua can do. And it's quite literally about 3 lines worth of programming to do something like that. It's not a hard thing to understand, but what's really unique about it, again, is it can really take this device and mutate it and make it do anything within limits, right? But it pretty much anything that you want to do to this device can be done in Lua. And one of the things that folks like to do with it is they like to, within Lua, configure the room controller. They like to set all of, I'm just going to use set points as an example. They want to set that, right? And they have Lua in the room controller, and every 24 hours, Lua will go back and reconfigure the set points, realign them. So how many of you out there constantly have, well, you know you want to have set points specifically to what I call as a prescribed set point in a building, that they're all over the place on a daily basis. Lua allows you, in a standalone world, Lua allows you to have that room controller sit on the wall and just automatically reconfigure all of that for you all day long. Typically, people do it when it becomes unoccupied, and then it goes occupied, and people make changes, and unoccupied again, then it does it. But you can base it on anything. You can do it on the light level sensor. You can do it on the door contact. It's pretty much limitless on what you can do with it, but it makes it very, very flexible to do many different things with it. And again, from a device that you just pull out of the box, put on the wall, and you don't have to have any licensing for it whatsoever, right? So this slide here talks about some of the part numbers, and we have basically 3 different versions. There's a Schneider Electric White, there's a Schneider Electric Silver, and then there's a Viconics. It only comes in white. And those are the different part numbers that we have for each one of them. There's 3 part numbers, and you'll notice on the far left, one comes with the temperature and humidity sensor. One is temperature, humidity, and occupancy sensor built onto it. And the other one is all of those things with the embedded Zigbee communications module built into it. And then below, those are the optional accessories that you can plug into it as far as cards go. Not the Zigbee sensors, but these are the things that you can add onto the room controller, like a CO2 card, the Wi-Fi card, which I've talked to, or you could put the Zigbee on it. The one thing to understand is there is only one slot. You can only put one of those three things in it. So typically, what I recommend folks to do is buy the P version, which has the Zigbee embedded in it, and that leaves the slot open that allows you to either put the Wi-Fi card in it and bring it in via IP, or you can put a CO2 card in it as well. And just one thing about CO2, we have a Zigbee wireless version of that, and then you can also hardwire CO2 into it. So having a module to plug into it's nice. You can certainly do that, but you can see where you can be limiting yourself if you put a plug-in CO2 module in it if you want to put a Wi-Fi card as well. So it can only be one. So only one of those can exist in this time continuum. So one of the things that I wanted to talk about here is the room controllers. We've talked about being BACnet capable and all the sequences of operation. One of the things that's important to understand is it has a time clock built into it as well. So it has a 7-day programmable schedule that has up to 3 periods per day for occupancy. So again, kind of going back to a smaller footprint and a smaller VAV application, this works really, really well without tying it into a network system because you can set your own time schedules within the room controllers themselves, and you don't need some supervisory system to do that. And if you have a Wi-Fi card built into it, you can actually have the Wi-Fi card sync up to the internet, an internet time server, so you can always constantly make sure that your time is in sync with the world, if you will. So one of the last slides here to talk about this product is the different devices that you would connect to that. Right? We've already went through the Zigbee stuff, but these two devices here are the things that you absolutely need to work on a VAV box. So the 8250 is the actual controller itself with the I/O built into it. These are examples of a pressure transducer, and a damper actuator that you would need to put on a box. Again, the damper actuator is 0 to 10 or 2 to 10. We can have others, but to have other type of some 0 to 10 volt signal range, you would have to write a little Lewis script to rescale that. But by default, we can handle 0 to 10 and 2 to 10, which is very common, not 4 to 20 milliamp, 0 to 10. And then on the pressure transducer, it must be a 0 to 10 volt unless you write a Lua script. There's no choice other than 0 to 10 unless Lua is written. You can do a 0 to 5 if you wanted to. And the reason for that is we give you the programming capability in the room controller on the HMI to scale it, right? So it's always 0 to 10, and it allows you to do any range of 0 to 5 inches. So if you wanted to have a 0 to 5, and it was a, what I want to say here, it was a 0 to 1 inch, you would just make that a 0 to 2 inch, and then at 5 volts would be 1 inch, right? So you have that capability to kind of fake it out, if you will, but at the end of the day, you need a damper actuator and you need a pressure transducer to make this work. And then obviously, if you want to discharge air temperature sensor, you would need that too. And we use any 10K type 2. Those are the resistive devices that can be wired into this device, 10K type 2. So with that said, I think this is I think we have like 10 minutes left. We've went through a lot to talk about this particular device and kind of recapping. Again, this is a device that's great for retrofit applications, whether it's pressure independent or pressure dependent, a VVT type application. It's all self-contained. There's no software. There's no licensing. There's no computers that are required. You can poke it in the eye and configure it. And when the air balancer comes, you can tell him the same thing, that he doesn't need a software, and nobody needs to hold their hand to open and close dampers and balance a box. It can all be done there. And at the end of the day, you also have the capabilities to add Zigbee devices to that. And if you have some troubled areas where you're having issues with temperature and you can't hardwire more temperature sensors back to an existing system, this is where this comes in and allows you to talk to wireless devices. And when you start adding that in together with the custom Lua programming, it's pretty much limitless of what type of application that you could put this on. And when I say pretty much limitless, the only thing that I can think that this is not out of the box ready to do would be a dual duct system, right? Doesn't mean we can't do it. It's just something that we haven't really looked at. And as far as an application goes, we don't see a lot of those. I mean, there's some out there, but we would have to take a step back and see how that could work with a dual duct if you have that type of application. But anything else, you should have no issues with it whatsoever. And all those VVT systems that have laptops running DOS sitting on a pickle bucket in an equipment room somewhere, this is a great replacement for that. So with that said, does anybody have any questions?
Okay, thanks, David. So we do have a couple of questions, and we're like running out of time, so I'll quickly go through those. So the first one's by John Zappa. He's asking, choosing between a pressure-dependent and a pressure-independent application, is that a selection choice in the setup menu, or does it need Lua programming to set up the difference? And secondly, with pressure-dependent, would you need the pressure transducer?
Good question. So the room controller, you configure it on the configuration screen to tell it that it's a pressure independent or pressure dependent. So it's all right there. So it's not a separate firmware or anything. You just tell it it actually says PI or PD, and you just select it. In a pressure dependent application, they don't use a differential pressure sensor to measure velocity out of the box. So there's no pressure transducer that's required for a pressure dependent application.
Okay, thank you. So the next question is by Aaron Ting, and Aaron's asking, does the new 8250 and or with the 8650 RTU controller meet the IECC FDD requirements in conjunction with economizer control?
So I'm not that familiar with that particular specification, but the 8600 on your RTU application has economizer control built into it. And we do economizer control in two ways. One, well, obviously we're controlling the dampers, right? But we do it with CO2, fresh air control, or we do it with temperature, right? And I'm sorry, I should probably say a third way. We also do it with an air monitoring station, which is completely unique. There's not many people that have that out there. So you can put an airflow monitoring station in and maintain an exact CFM of air that's coming in through your economizer, or you can do it via CO2 control, or you can do it strictly on temperature. Those are all conservation measures that are built into the 8600 itself. Hopefully that answers that question.
Okay, great. Thanks, David. I don't see any more questions. If you have any questions, please type them in the GoToWebinar panel, and we'll get those answered. Here's a couple of questions in the meanwhile, David, that I had. Does this controller require software to configure and use the SEZ 8250?
That's a good question. No, not out of the box. So if you're planning on using just a standard operation, it's just quite literally pull it out of the box and again, poke it in the eye, if you will, to configure it. No software whatsoever. But if you want to do anything that's unique, something special, again, you would just use any text editor to create a text file, and then you would use that uploader tool, that free software tool that we have, and it's a USB connection from your laptop into the room controller, and you upload that special program into it, and that's it. Unless you're connected via BACnet. If you're connected via BACnet, then you can send that program via BACnet, whether it's MSTP or Wi-Fi IP to it as well.
Oh, great. Okay. Yeah, thanks. And also, like, are there any licensing fees to it?
Again, that's a great question. No licensing fees whatsoever. So when you buy a room controller, doesn't matter what room controller it is, whether it's this one or any of the other 8000 series, there's no licensing fees with it whatsoever. You just buy it, it's yours, you own it. Now, with that said, if your computer server on your BMS side has a requirement for licensing any of those BACnet objects that come out of it, that's something completely separate. But as far as the room controller goes, it doesn't care. It's a device. It is available, freely available. All the BACnet objects that are built into it are for yours to use.
Okay, great. Thanks. Yeah, thanks for a very in-depth presentation about this controller, David. Yeah, looks like we do not have any more questions, and looks like we are almost out of time. So, last call for any questions before we wrap this up. Okay, David, looks like you answered all the questions. And again, thank you very much for a very in-depth presentation. It's a great, versatile product you guys have. And thanks again.
Thank you. Thank you very much for the opportunity to speak with everybody here. I appreciate it. And I wish everybody the best of luck. And don't hesitate to reach out. I believe, Harshal, you, within your organization, you're providing support, I believe, on the product line.
Yeah.
Is that accurate?
That is correct. So I want to just update the audience that we do provide support for the SE8000 controllers on our site, ControlsCentral.com. So please go ahead and utilize that. And yeah, we have all the Schneider products in stock as well. So
that's great. And I would just add one more thing. I know folks are dropping off, and I want to put a quick little plug in here too. Our new cloud offering is being released in April, and the 8000 series product line, the VAV is not available today, but it's really at the 8600, the RTU type level, but the VAV will be available soon. With the Wi-Fi card into it, you can get your RTU controllers right up to our cloud and have access to all of your customer sites, all of your room controllers, O&M manuals, pictures, service work order tickets, all of those types of things. Those are all being made available in our new cloud solution. We've had one for about probably going on 6 or 7 years now, but we've completely been revamping it over the past 6 months, and we're rolling it out in April. So any applications where you have someone that wants a phone app or a tablet app as an end user, and you want to have access to it in the cloud, that's coming out from Schneider. So all of that stuff's available from Schneider as well. But thank you for the time. I really appreciate it, everybody.
Okay. Thank you, David. Thanks again. And thank you all for joining us. Just a reminder, we will be sending out a recording of this webinar. So you can still view it later on demand, or share it with your colleagues. And thanks again. Have a good day.
Bye-bye, everybody.